Okay, so we're going to look at 10.2 here. 10.2 is all about products and quotients. So products is multiplying. Quotients is dividing. So we're going to multiply functions, and we're going to divide functions. It's pretty much the exact same thing as yesterday, except for yesterday we added and subtracted, right? And today we're multiplying and dividing the functions. Okay? So when we look at the product of a function, they can write it like h of x is equal to f of x, and they'll put a dot times g of x. Or they'll just write f of x times g of x. Or they can combine it like they did last time with the brackets around the f times g and then bracket x. Okay, so very similar notation to yesterday, except for where there was plus and subtraction signs, they're now multiplying signs or division signs. So if we have x plus 3, which is a line, and we have g of x, which is 2x minus 1, which is another line, right? If we have those two things, we multiply them. Realistically, we can write them as x plus 3 times 2x minus 1. How do they actually come up with this number? They distribute, they FOIL. X times 2x is 2x squared. X times negative 1 is negative x plus 6x minus 1. And then we combine, right? 2x squared plus 5x. Oh, I can't even multiply. 3 times negative 1 is negative 3. Okay? To get a new function. Okay? This new function, when we multiply, we got x squared x in a number, which we know is a parabola. Okay? And so how do we come up with parabolas? Well, we can move it into, like, how do we graph it? You can really move it into vertex graphing form, like if you remember from any time. But that's kind of crazy, vertex graphing. The other thing you could do is, what? For each point, find your f of x, find your g of x. How do you find the h of x point for that x? You multiply. So if we take a look here, here's our g of x, here's our f of x. So let's look at like this point right here. We have 1, and down here we have negative 5. Negative 5 times 1 will give us the point on the parabola of negative 5 as well, right? We can find other points, like here, this is negative 1, and up here, this is positive 3. 3 times negative 1 is negative 3, which is on the parabola at that point, right? So same kind of concept as yesterday with the adding and subtracting, except for now we multiply the points, okay? Now, if you wanted to graph and you didn't want to multiply each point of the x, how else could you actually figure out to draw this parabola? Yeah, I'm going to say table of values x and y, right? So, yeah, you can use your graphing calculator and get that table of values, or you can just pick some points, negative 2, negative 1, and then keep on working until you see like an actual parabola shape, okay? The division of functions, does yours say difference or does it say division? Because isn't difference subtraction? Okay. Should be the division or quotient if you want to go there. Okay. That's basically dividing. Yeah?
Do you get these formulas, or do you have to remember them to leave them down?
For what formulas? There are no formulas. Because in the question, they write f of x plus g of x, right? or they write f of x times g of x, right? They write that in the question, and you've got to look up the functions and do that addition, subtraction, multiplication for them, okay? So if you look, there's two different ways of writing it, f of x divided by g of x, or f divided by g in brackets of x in brackets, okay? So two separate ways of writing it. It's the exact same way that they've written it for multiplication, addition, and subtraction. They just put a different symbol in there, okay? This is f of x is equal to 3x minus 1. That is a line, right? So negative 1 up 3 over 1 up 3 over 1 gives us that graph, right? So this is f of x. G of x, does yours say x squared minus x? Okay, x squared minus x, that's a parabola, right? That's this parabola right here, to tell you the truth. And then when you do the division, it gives you 3x minus 1, all divided by x squared minus x. Now, we don't know what that is yet. That's a rational function. Chapter 10 teaches us how to graph rational functions. For right now, we really don't need to know how to graph them, but we do need to be able to come up with contents, like come up with numbers. Come up with like the values, or come up with the equation, because we can come up with this equation, right? Now you should be able to factor, because we can factor. This becomes what? A 3x minus 1 over an x times x minus 1. If we were able to take the factor off the top and the bottom, like you've done before, we could cross them out. But because there's nothing we can cross right off, that's the answer. So you could leave it like this, or like that, and that would be okay. But if you look, this is doing a thing like this, here, and then there's this thing that's going through here, and then there's this thing out here. That's the graph of what's going on there. How are we getting this graph? I'm guessing. We're just going to guess. I would put it into my graphing calculator and look at it, and then you could copy like you guys have been copying in your past classes, right? Now, what else could you do? You could do the whole division thing that we've got going on, right? So if I go back, my f of x is right here. It's negative 4, right? My g of x, I can't see, right? Where's my g of x? Is my parabola. Oh, right here. Is at 2. So what's f divided by g? Negative 4 divided by 2, which is negative 2, which is this point right here, right? I could also do it continuing on over and find every single point, okay? I'm probably not going to ask you to graph them rather than solving the equations and coming up of, let's say I wanted to know what f divided by g of 3 was, right? So, what is this? How would I solve this? Plug in 3 for every single x, right? That's what it means in the f divided by g, okay? So that'll give us 3 times 3 minus 1 over 3 squared minus 3. 3 times 3 is 9, minus 1 is 8, over 9 minus 3, 6, which gives me 4/3. And that, I think you guys could do, okay? So, domains are all the x values, right? Usually, domains get restricted when the domain of the first one and the domain of the second one are different domains. Now, if we look at the line and the parabola that we just had above, the line and the parabola both have x's and elements of the reals, right? Line continues on forever, parabola continues on forever, right? But there's a point in this graph where things don't exist. When do things not exist for x's? When you're dividing by 0, okay? So in this case, it's going to be when our g of x equals 0, our domain does not exist, right? So going back to this graph that we've got going on here, we need to find g. G is right here, right? So at this point right here, and at this point right here, it doesn't exist. What are those points? At x equals 0 and x is equal to 2, right? Other than that, all our x values exist, okay? So, but when are we talking about? At 0 and 1 is where g of x equals 0. Oh, sorry. You're right. I'll give it to you. So how do we write that is what I want to ask you, because there's 2 points that don't exist, but the rest exist. Like that, okay? Lots of times they'll write x is an element of the reals, x cannot be 0 or 1. Another way that they write it is that x such that it is from negative infinity to 0, from 0 to 1, from 1 to infinity, x is an element of the reals, and we should have unions in here, right? Which way do I prefer? Yeah, the top one, right? Should you be able to read the bottom one? Yes, you should be able to read the bottom one. We did those kind of things already, right? With the closed brackets and open bracket kind of thing. They're little U's for union. Or should they be ends? They probably should be ends for and, right? Not or. Okay. Now the y values, are your range, right? We got to look at the graph. When we look at the graph, it's carrying on all the way down, down and up and up. So all the y values, right? So the range will just be y such that y is an element of the reals, okay? So, example, determine f of x times g of x and k of x, which is f of x divided by g of x for each pair of the functions. So this first one, h of x is n, what would I write? Okay. Then you FOIL. Don't leave it like this. Actually expand out. What do we get when we expand out? Okay, am I done here? No, we probably should combine our like terms. We get 4x squared minus 8x plus 3. That's it. That's h of x. If you did that, you'd come back up here, right? Because that factoring is the opposite of FOILing, to tell you the truth. So what is k of x then, right? Can I erase this and go to k of x? Okay, what is k of x? K of x is f of x over g of x. I think that's what it said in the question. So you're right, it's 2x minus 1 over 2x minus 3. I can't factor them to cross anything out, so that's it. We're done. Okay? If it asks for a restriction, what can the denominator not equal? So I'm just going to write restriction. 2x minus 3 equals 0. So x is equal to 3 divided by 2. So x cannot equal 3 halves. Why can it not equal 3 halves? That's where that bottom or the divide by 0 is, right? And so that doesn't exist there. In the graph, you'll have a big asymptote at that point. Okay? So they want us to do the same thing for b, right? So find h of x, which is f of x times g of x. What do we get? We get 3x times negative x squared minus 4. What should you do then? Negative 3x cubed minus 12x. What do you have there? You have one of those polynomials, right? Okay. One of those fancy polynomials that we all know and love from Unit 2 or 3. Okay. Are we done? If you pull it out, you'll end up with this thing, right? So we just expand it out and leave it be. That's what h of x is. Okay. What was k of x? K of x was f of x divided by g of x. Okay. So what do we get? What's f of x? 3x divided by g of x, which was negative x squared minus 4. Even if we factor it, we'd pull out a negative 1, we'd get x squared plus 4. You can't cross anything out, so this would be where I would leave it. K of x is equal to this. Can we figure out a restriction? Is there a restriction? No matter what number we put in for x, it'll be, right. So we have negative x squared minus 4 equals 0 if we're going to look at the restrictions. So we'd get negative x squared plus 4. X squared is equal to negative 4. That, you can't do that, right? You can't take the square root of a negative number. So then there's no restrictions. So there's going to be no asymptotes is really what it means. Okay? Whew. So our next example says f times g of negative 1. What does this really mean? F of negative 1 times g of negative 1. Right? That's what it really means. So find the x value at negative 1. Right? X value at negative 1 is here. Right? All the way up. So f of negative 1 is 4, negative 4, times g of negative 1, which is 5. Negative 4 times 5 is, and that's my answer, right? F divided by g of 1. F divided by g, 1. What's that? That's really f of 1 divided by g of 1. What's f of 1? 2. And what's g of 1? Negative 3. So we get negative 2/3. G divided by f of 0. So that's g of 0 divided by f of 0, right? What's g of 0? F of 0. And so 0 divided by negative 1 is, okay. Now, this last one here says g times f of 3. How do we write that? G of 3 times f of 3. What's g of 3? Negative 3. F of 3? Oh, good, you can see it, I count. 8. Negative 3 times 8 is negative 24. Okay? This is the same thing we do with the plus or minus graphs, right? It's just you multiply or divide this time. Now it says, do the sketch. Awesome. F times x. Okay? So if I look at this, I can only deal with the points that I can see. Okay? So I can only see a point here, so I'm going to deal with negative 2 to positive 3. That's the only thing I'm going to draw the graph on, because that's the only thing I can see these points till. Okay? So when I look at this, g of x is the diagonal, f of x is this. My f of x is always 4, right? Is my answer all negative 4, right? So negative 4 times negative 5. Negative 4 times negative 5? Positive 20. I can't even draw that, can I? This is really bad. But this is plus 20 up here at this point. Okay, so it really won't help us right now. This next one here at negative 1 is negative 4 and negative 3. Negative 4 times negative 3, positive 12. Way up here, positive 12. Hopefully you would have a big enough graph to draw this, right? But we don't for some reason, because your teacher is silly sometimes. Negative 4 times negative 1, positive 4. So that one I can draw in. Do you guys notice what's happening? 20 to 12 to 4. Down 8 over 1 each time, right? If you notice a pattern and it's going to be a linear pattern all the way, it might be, okay? So I'm just going to do one more and see if I notice a pattern. 4. Where am I? 4 times negative 1, negative 4 times 1 is negative 4. And that's down 8, right, again? And so you can just continue on. Negative 4 times 3 is negative 12. And then the next one would be negative 20, right? But we just don't have the graph to draw it. But we can see that it's going to do this thing. This straight line thing that's going on here. I can't even draw a straight line. I can't even draw a straight line. It's so straight. Are you guys okay? Why are we throwing around at each other all day? Nothing. Okay, never mind. I don't know. Okay. Same thing here. You can only deal with the points that you got. Okay? So I can only go from negative 2 to probably positive 3, and it's just dividing. So f is always negative 4, so it's negative 4 divided by something all the time, right? So negative 4 divided by negative 5 is negative 4/5, right? No, positive 4/5. So somewhere in here. The next one is negative 4 divided by negative 3. Negative 4 divided by negative 3, positive 1 1/3 or positive 4/3. Then I have negative 4 divided by negative 1 is positive 4. Then I have negative 4 divided by positive 1. Negative 4 divided by positive 1 is negative 4. Then I have negative 4 divided by 3. It's negative 4/3, right? Right here. Then I have negative 4 divided by 5 is negative 4/5. Okay? Now, the thing to remember is when you're dividing by, you have to remember that your denominator, when it's 0, you get a asymptote. Okay? So where's my denominator 0? Right here, right? That's where my denominator is 0. So I draw this line. Okay? Can you see what your graph is kind of doing? I think it looks like this if I actually hit my points. Because if you do negative 4 divided by a bigger number, you're just going to get a smaller and smaller negative fraction, right? And if you get negative 4 divided by a negative number, you're just going to get a smaller and smaller positive fraction. Okay? Now they just get into a little bit more detail. F of x times g of x times h of x. It's the same thing, it's just more algebra. Where do we make our mistakes? Algebra. Okay? So f of x times g of x times h of x, how would I write this? Determine each combined function. Well, we can FOIL the first part, right? We get 4x cubed minus 5x squared, and that's times root of x minus. And I would just leave root x minus 1 by itself, because that's like x minus 1 all to the exponent of 1/2, and we're not going there. Okay? Now, is there restrictions on x? In this case, there will be a restriction on x. Why not y? We have a restriction here even though we don't have a dividing. Why? Because you cannot take the square root of a negative number, right? So what numbers, anything less than 1, right, will give me a negative number. So my restriction says x has to be greater than or equal to 1. Because anything other than that will make me take the square root of a negative number. So my restrictions now if we're going to write g of x times h of x, that's just what? X squared, no, that's not g, that's f. G is 4x minus 5 times h of x, which is root x minus 1, all divided by x squared. That's just combined as we're going to get, because we're not multiplying by the root sign, right? And we're here. So we have some restrictions. One of our restrictions is x has to be greater than 1, right? Greater than or equal to 1. Now, that's just from here. But what about this thing? Why can't it equal 0? Because 0 squared is 0, okay? So how should we write our restrictions? We probably should do this x such that x cannot equal 0 and, or just put a comma, right? X has to be greater than or equal to 1. X is an element of the reals. Because we can have all the decimals in the world if we want, okay? But you have to use both restrictions, okay? Because they're both things that make it awful. So last questions, hey? H of x is equal to f of x times g of x, and f of x is equal to 2 minus x. Determine g of x. That's a little different, hey? Okay, so h of x is equal to this, but it's also equal to f of x times g of x, okay? And we know, right, but we have to include the 0 to 1, like the numbers in between 0 and 1. So let's go back here, because we could write it a little differently too. We could write this restriction so that it was x such that not including 0, but including 1. Oh, yeah, I agree with you. So we could say that x had to be greater than or equal to 1 because this restriction is not included in greater than or equal to 1. Do you guys see how he's saying that? So you don't have to make separate things. If the cannot equal was included in the greater than 1, like if it couldn't equal 3, then we'd have to state both. Okay, but because 0 isn't even included in this, I agree with you, we don't have to. But let's go through and figure out how we can figure out g of x. X squared minus 2 of x is equal to 2 minus x times g of x. Are you guys okay with me inputting that? So I just inputted what they stated f of x was. Okay? How do I get g of x alone? Divide by 2 minus x. I agree. So now I've got g of x. This looks close to something in the top, right? Can I pull like a negative x out? If I pull a negative x out of the numerator, what am I left with? Negative x plus 2, right? And this is 2 minus x. Is negative x plus 2 the same as x, or 2 minus x? It is, right? So we can cross this out, and then negative x is equal to g of x. Okay? How can you double check to see if you're right? Take your g of x and times it by 2 minus x and see if you end up with x squared minus 2x, right? Now, B looks interesting, but do we have any restrictions on x for this first case? I don't think so, right? There's no real restrictions. We're multiplying. There's no square roots. So I would say no restrictions. But let's look at B. We know of x is 2 minus x, and we want to know h of x is equal to the square root of x squared minus 4, and that's equal to f of x times g of x, right? We can put an f of x in, right? So we've got root x squared minus 4 is equal to 2 minus x times g of x. Divide by 2 minus x, right? Just like we did before. So we get g of x. What do you guys notice about that x squared minus 4? Please, oh please, please say you could notice this. It's a difference of squares. X squared minus 4 is a difference of squares. What's a difference of squares? How do we factor that? X plus 2, x minus 2, right? Does that help us? We can't cross anything off, right? Can we do something? Could that just be what g of x is equal to, you guys? Negative x plus 2. No, you guys, I think we can't do anything more. Like, you can't reduce, we can't pull it. Like, if it was a trinomial square, at least you'd have x plus 2 all squared, and then you can take the square root of that. But this is it right now, right? Because if we square both sides, we're going to end up with g of x squared. And so then we're going to end up taking the square root. So sometimes you think that, oh, I should be able to simplify more, but you can't. So, yeah? Like if you did, like what I'm saying is, this is the final answer, right? Because even if you do the difference of squares, you can't cross anything out, so this is it. But do you have restrictions then? X cannot equal 2, right? Now we got to be careful. If we put 0 in, 0 minus 4, there's going to be some restrictions on this root sign, right? And what is it? X cannot be less than 4, and negative 4? Because we can put some values in here, right? If we put negative 2 in, negative 2 squared is positive 4. 4 minus 4 gives us 0. If we put negative 3 in, negative 3 squared will get a positive. What if we put negative 1 in, though? 1 minus 4 will give us a negative number. So x cannot equal anything between including? No, because we can take the square root of 0. So x cannot equal anything in between negative 2 and 2, right? Because any of those numbers will make it a negative underneath the square root side, okay? But x cannot equal 2, so then we should include this as a square bracket, right? So, for homework, we're going to look at doing a couple of them, but we'll see how it's going. We're looking at 10.2. 10.2 is on page 496. Let's look at 1 and 3 and 6. Okay, so you want to try that? 1 and 3 and 6. 496. Sure. Page 496, 1 and 3 and 6.